Hi, I'm Peter Hawley, President and CEO of Fabled Copper Corp, and today I'd like to tell you about the Aster survey on the Bronson property. What is Aster? Stay tuned and you'll find out. The Muskwa project is composed of the Neil property, the Toro property, and the Bronson property, all located in northern British Columbia. We have started reporting on the Bronson property with the various surveys conducted on the Book 6 copper occurrence, which included the UAV drone mission, sampling, geophysical surveys, and structural interpretation of the Bronson property. And today we'll talk about the findings over the entire property using Aster. The Bronson property comprises 4 mineral tenors covering approximately 2,524 hectares, where the key objectives of the 2021 work program was to carry out field campaign consisting of reconnaissance prospecting across the Bronson claims. Number 2, complete a focused program at the Book 6 vein targeting, which includes detailed sampling, very low frequency electromagnetics, ground magnetometer, geophysical surveys, and a UAV photogrammetry survey, of which we've reported on to date. And finally, the third thing, which we'll be talking about today, is we conducted alteration mineral mapping and targeting using various infrared and spaceborne thermal emissions and reflection radiometers, or Aster, multispectral satellite data. And as I said, we'll be talking about this today. So here we go. Let's talk about the Bronson property and the Aster alteration mineral mapping results. The Aster sensor is a spectral imaging instrument located on an onboard EOS Terra satellite, which was launched by NASA in December 1999. Aster has been designed to acquire land surface temperature, emissivity, reflectance, and elevation data, and is a cooperative effort between NASA and the Japanese Ministry of Economic Trade and Industry. Aster consists of 3 separate subsystems. Each acquire data from different regions of the electromagnetic spectrum, and each Aster scene covers an area of 60 by 60 square kilometers. The VNIR bands have spatial resolution of 15 meters, whereas the SWIR, or the swirl bands, have 30 meters and the TIR bands have 90 meters. And an additional backward-looking infrared band provides stereo coverage. The Aster channels are more contiguous in the shortwave infrared region than those of the Landsat, yielding increased accuracy in the spectral identification of rocks and minerals. And this was identified by Gabriel et al. In 2010. Aster can acquire data over the entire globe with an average duty cycle of 8% per orbit. This represents acquisition of about 650 scenes per day that are processed to 3 different levels based on final product. And that's level 1A, 1B, and 1T. All processed scenes are transferred to the Earth Observing System Data and Information System. And this is archived at the EROS Data Center, Land Processing Distributed Archive Center. And this is for storage, distribution, and processing to higher level data products. All Aster data products are stored in the hierarchical data format. Aster level 1B products used in this study represent registered radiance at the sensor product, and as such contain radiometer calibrations and geometrically co-registered data for the acquirement channels. And level 1B data is produced by applying the radiometrics calibration and geometric correlation coefficients to the level 1A data files. Further, image priority processing is required to generate surface reflectance and emissivity multiband imagery that is necessary for mineral mapping and analysis. And scenes used for mineral mapping must predate April 30th, 2008, where SWIR sensor overheated and began resulting in erroneous data for the 6 swirl bands. So, as you can see, one minimal cloud covering Aster level 1B scene was acquired for the Bronson claim block. The mapping area is characterized by minor snow and ice cover and moderate vegetation covered at a low elevation. These image feature types, in addition to topographic shadow, will significantly reduce surface area over which spectral analysis can be carried out. The imagery was acquired on September 11, 2001, and the Canadian digital elevation data is 30-meter resolution, or the DEM, was acquired and used to correctify the Aster scene. Note that the crosstalk is an effect in Aster imagery caused by signal data leakage from bands 4 into bands 5 and 9. A crosstalk correlation is applied using an open source software. Other necessary pre-processing steps after data import include 1. Image deorthification using available DEM, layer stacking in the Vinar and Swirl 9 bands, layer stacks, and these are resampled at 30-meter resolution, and the Tier 5 band stack at 90 meters unresolution. And finally, atmospheric correction for the VNIR swirl data to generate surface reflection data. The thermal atmospheric correction for the TIR data was done to generate emissivity data, and trimming and mosaic stacking to the Bronson claims. And finally, the snow cloud and vegetation masking and the VNS swirl image was atmospherically corrected using the model fast line of sight atmospheric analysis of spectral hypercubes, or FLASH. Now, saying all this, the models have been shown to be better than other atmospheric correction techniques for hydrothermal mineral mapping. Now, to make it even more complicated, let's discuss the band ratios and logical operators. Selected Aster and VNIR and SWIR and TIR bands and logic operators are extremely effective in mapping hydrothermal alteration for reconnaissance or early stage exploration. The following focuses on minerals that yield credible anomalies such as a gauzen or silica and general clay. Note that vegetation was masked out of the final products to avoid generation of false anomalies. You may ask why, but vegetation has a spectral response that overlaps with clay minerals that are identified using absorption and reflection features in the swirl portion of the electromagnetic spectrum. Important observations include 2 north trending linear anomalies occurring at the Book 6 and the 428 south occurrences respectively. A northeast trending gauzen anomaly occurs approximately 500 meters northwest of the Bronson claims also, whereas 11 areas of silica alteration are present in the Bronson claims, including a large anomaly immediately west of the claims, and it's not known where this anomaly is related to stratigraphy or mineralization, and certainly warrants investigation. So, to sum it all up, 15 areas of anomalous gauzens and silica mineral alteration targets have been identified both on the Bronson claims and immediately adjacent to the claims that warrant following up this summer. Imagine you can find all these targets from a satellite above. Hard to believe. Going forwards, Aster mineral alteration mapping over the Bronson property reveals several areas of silica and gauzen probable alteration. A total of 15 anomalous zones warrant field follow-up and reconnaissance of newly defined Aster alteration anomalies. Follow us while we explore for fabled green copper in northern British Columbia.